Okay, everybody, welcome to another con support video. This one's on writing fractions as repeating decimals. So the first problem on your activity was 11 over 44. So if we're going to look at that one, 11 over 44, that would just be 11 on top, 44 on bottom. Now, when we look at this one, 11 over 44, that is actually not a repeating decimal, right? Because you can simplify that by dividing top and bottom by 11. And when you do that, you get a 1 over 4. So this is actually just 1/4, which, as you guys know, when you multiply top and bottom by 25, you're going to get 25 over 100. So this is just 0.25. So this is not a repeating decimal. This is just a terminating decimal. So this was a trick question, I guess. And you just go to C, which is a 0.25 terminating decimal, and you're done. Okay? And then the next one. Okay, this one is 29 over 37. So let's look at this one, all right? So number 2 is 29 over 37. So let's zoom in here and do this one. This one looks a little bit nastier, like a little harder, right? So let's investigate this one. 29 over 37. So that's a 29 on top and a 37 on bottom. So when you're doing this problem, you're going to just do top divided by bottom, because I don't see anything I can multiply the 37 by to get a place value like 10, 100, or 1,000. And I don't see anything I can divide top and bottom by that's a common factor of both 29 and 37. So that means that you're just going to say, all right, the top number goes inside, the bottom number goes outside, and you're going to do your division. So add your decimal and do your math. So the top number is always what goes inside, right? So it's always top, and then it's divided by the bottom. And you're going to divide by the bottom. And let's put the bottom on the outside here. So you can see top divided by bottom. I'm going to change the bottom to being the blue so we can kind of color code this one. So this is really, how many times does 37 go into 29? Because you're dividing by an integer, you're just going to bring the decimal up exactly where it's located. You don't have to move the decimal. And then we're going to say, okay, how many times does 37 go into 29? 0. How many times does 37 go into 290? Well, let's just make a little list for ourselves on 37. You got 37, right, which is just 137. And then if you double that, you've got 60 plus 14, or 74. That's 2. And then if you were to, let's say, double the 74, so this is kind of like 2. If you were to double the 74, you'd be looking at 4 of these things, right? Kind of get a little number here working for us. And so that would be 140 plus 8, right? Because double 170 is 140 and double 4 is 8. So we're looking at 148 for 4 of them, right? And if we did, let's say, 5, we would just add 37 to that. So if I wanted 3, I could add 37 to the 74, and we get 11, carry the 1, 4, and 7, 11. So you're looking at 111, right? That would be 100 plus 11, so 111. Then this one, you're going to add 37 to it to get 5. And you're going to get 148 plus 37, so that's plus 30 is 178. And then plus 7 more would be 178 plus 7, which is going to be 200. 178 plus 7, which is going to be 185, right? So anyways, now I've got a sense of the first 5 values, right, of 37. So that helps make a little table for myself that I can start to work with. So I'm looking at this one, 290. It looks like it's quite big. If I doubled the 4, that would be 280 plus 16, so 296. That's a little too big. So I don't think it's going to be 8, but it's really close to that. So my guess is it's going to be 7, okay? So if I did 37 times 7, that's probably going to be the right number. 7 times 7 is 9, and so I got 49 there. And 7 times 3 is 21, plus 4 is 25. So we got 259. So let's do that. So let's put 7 in here and 259, and let's subtract. So then we're going to go through and do the process. 0 take away 9 can't do it. We're going to borrow from this, make it 8. This becomes 10. 10 take away 9 is 1. 8 take away 5 is 3. And so we have 31 left over. That was the perfect answer, right? We can't fit another 37 in, so this is good. So you have these 31 left over. Then you're going to add a 0 and bring down. So we're going to kind of just do the next level, add a 0 and down. Now we got 310. Now I think we could fit the 148 doubled, right? Because 148 doubled was 200 plus 80 plus 16, so 296. So that will definitely fit. So we can now say that we're going to use that value. So we're going to put 8 here, and we're going to say that this is going to be 296, like we said, because 37 times 8 should be 296. Let's just double check it, make sure we didn't make any silly boo-boo. So over here we can say, let's do it over here. 37 times 8. 8 times 7 is 56. 8 times 3 is 24, plus 5 is 29. Yeah, that's right. So then we have, how far is it from 296 to 310? It's 4 to get to 300, and then another 10. So I would just say that's 14. It's pretty easy. And then we're going to add a 0 and bring down. So now we're looking at 140, and that's why I come in this table. We can see that 3 would work, but 4 is too many. So now it's going to be a 3. So we know this is going to be a 3. And then 3 times 37 is 111, so that's going to be 111. We subtract, and that's kind of helped us. Now we have that table to work with. And so it's going to be from 111 to 140. It's 9 to get to 120, and then plus 20 more. So we're looking at 29. And then you're going to add a 0 and keep going. And what you're going to notice here at a certain point is it's going to start to repeat, okay? And what I'm saying right here is it starts repeating right now, because when we looked at our original problem, right, what are our first 3 values? 29, and we added a 0 on the end, right? So that was 290, and we said that goes in 7 times. So when we get this 290 down here, it's going to go in 7 times as well. So that tells me that the repeating element is going to be this 783, right? It's going to be 783, 783, 783 forever. So you put a bar over the 783 because it's going to repeat with that 7. So this is going to be a 7 again, right? And it's going to repeat over and over again, 783, 783. So this is a repeating decimal and a BB, which is 0.783, repeating with the bar over all 3 of those things. So that's what you write. And then the next one is 27 over 32. So let's do 27 over 32. Let's see if it's an easy one or not such an easy one. Let's find out. So 27 over 32, this is number 3. So the first thing you want to ask yourself is, can I divide top and bottom by anything? Well, this is a multiple of 9, but this isn't, so it doesn't look like anything goes into both of those two. So then you are going to just do top divided by bottom. So the 27 goes inside and the 32 goes outside. Now you could make a little table for yourself over here, right? 32 is 1, and double that, you get 64, and then add 32 more to that, you get 96. And then if you add 32 more than that, you get 98 plus 30, which is going to be 128, right? Because we'll be 106, which is 10, and then 116, and then 126, and then the 2 extra. So yeah, 128. And then you could add 32 again if you wanted to, and you could get what it looks like 10, carry the 1, so that's going to be 4 plus 2, which is 6. So it's like 160 there, right? So anyways, you can see this is 1, this is 2, this is 3, this is 4, and this is 5. And then from there, you can kind of double things if you need to get sizes. So I would recommend doing the first 5 multiples of the thing you're dividing by, and then you can kind of go from there. So 32 into 27, obviously that's not going to work. So you're going to bring a decimal up from the end exactly where it is, because you're dividing by an integer. You don't need to move the decimal place. And then you just go through and do it. So this is 270. This is 160. Double that's going to be too big, obviously. It's 10. 128 doubled would be 8. Let's see what that's going to be. That's 200 plus 40 plus 16. So 256. That looks pretty good. So it's going to be 8. And 8 times 30 is 200. So 320. No, sorry. 8 times 30 is 240, and 8 times 2 is 16. So we're looking at 256. And you're going to subtract, okay? So now we're going to subtract, and we're going to see what's left over. So from 56 to 70, it's going to be 4 to get to 60, and then 10 more, so that's 14. There's a difference of 14 there. And then you're going to add a 0 and bring down. Now you've got 140 to work with. We know that's going to be 128. We already have that set up perfectly for us. So that's going to be 4, which is going to be 128. There's 12 difference there. That's pretty easy, because from 128 to 130 is 2. then an additional 10 to get to the 140. And so then we can, of course, go to the next 0. Let's put a 0 here and bring down. And we're looking at 120 here. Now, there's no other times that's occurred, so we've got something to look at there. It looks like 128 is too big. 96 looks pretty good. So let's do 3. So that's going to be 96. How far is it from 96 to 120? It's 4 to get to 100 plus another 20. So it looks like 24. So that means that your difference there is going to be 24. And then you're going to add a 0 and keep going because it hasn't repeated yet. So we're going to keep going. 240. Now, 240 would be what? Looks like it's close to the 5, right? 5 plus 32 is going to be 160 plus 32, which is going to be 192. So that's going to be 6. And then so that means 7 would be 32 plus that, which is going to be 194 plus 30, which is going to be 224, right? So when we look at that, we got 224. That's going to fit pretty well there. So it looks like that's going to be a 7 there. And so now we're looking at 8437, and then we're going to have the 224 down here. How many times does, or what's the difference between 240 and 224? Okay, well, from 224 to 230, it's 6, and then from 230 to 240, it's 10. So 6 plus 10 is 16, right? So 16. And then we can, of course, add another level to this. This is fun. And bring it down way all the way down there, and we get 160. All right, I don't see that repeating anywhere yet, but I say, oh, wait, this is 160. Bing, 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 bing. So this one is not a repeating decimal. They were messing with us. It's not a repeating decimal. It's a terminating decimal. So it goes perfectly in 0.84375. So this is actually worth 0.84375, and it terminates. It's not repeating. They tried to trick us. 0.84375, and that would be right there. 0.84375. Very nice. Okay, the next one, 41 over 90. All right, let's look at this one. So this is 41 over 90. Let's do this. Number 4. 41 over 90. Now, I'm going to teach you guys a little trick here on a multiple choice test. You can eliminate some things that just don't make sense, right? So 4/9, which is close to 41 over 90, is going to be 0.44 repeating. So obviously, these two are going to be probably wrong. It's going to be either 0.45 or it's going to be 0.45 with the 5 repeating, right? So it's probably one of those two. So that's a way you can eliminate wrong answers on a multiple choice test. Let's go through and do it. So it's 41 divided by 90. There's no common factors that I see there, a way of simplifying it. So you're going to bring the decimal up exactly where it is. 90 is a really nice number to work with compared to the last one. So let's just work with it. How many times does 90 go into 410? Well, 9 times 4 is 36. So that means if you have 4 here, it's going to be 360. So that looks pretty good. And then from 360 to 410, it's 40 plus 10, so that's 50 difference, right? And then you're going to bring down a 0. And so far, I'm feeling much better about this one, right? So this is 90 into 500. Well, what would I multiply 9 by to get close to 50? 9 times 5 is going to be close to 50, it's going to be 45. That means 90 times 5 would be close to 500. It's going to be 450. So when we do that, it's going to be, oh, wait, it's 50 again. This is cool. So this one's going to repeat. So we can see here that the 50 is repeating, right? Which means we're going to get the 500 and it's going to repeat, which means that we're going to have 5 that's going to repeat, right? So that means that 5 is going to happen over and over and over again. So the answer is just going to be 0.45 with the 5 repeating. So this isn't a trick question. It is a repeating decimal, 0.45 repeating, but just the 5 repeats. So that's going to be the answer. All right, the next one. That wasn't too bad. Let's add a new page. We'll do the next problem. So this next problem that we're going to do is 63 over 75. So in this one here, you got number 5? Yeah, number 5. You got 63 over 75, which means we're going to have 63 divided by 75. And 75 is not too bad to work with, right? You guys all know 75 pretty well. 75, 150, 225, 300, 375, plus another 75 would be 450. And then, you can add another 75 if you want, 525. And you can keep going with that, right? But it's pretty simple. You guys know your 75 is pretty well, probably. So let's do 525 there. Okay, cool. So I'm going to kind of go through and use that as a little help when I'm going through and doing a problem. Make it quicker for myself. Little table sometimes helps there. So now we've got bring the decimal up exactly where it's located. When you're dividing by integer, you just bring the decimal up exactly where it's located. And we're going to do it. So 75 into 630. Well, if I add 75 to 525, I get 600. So that seems like it's pretty good, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, right? So 75 times 8 should be 600. Because 2 is 150, and 150 goes into 600 4 times. So 2 times 4, 8, right? That makes sense. And then we're going to subtract. We get 30 left over. Then you're going to add a 0 and bring down. And now 75 into 300, that goes perfectly. So that's a terminating decimal on 300. So we're done, actually. That's going to be 4. And so this answer is actually, that is not a repeating decimal. It is a terminating decimal. So 63 over 75 is actually equal to a terminating decimal 0.84. And you don't need any repeating element on that at all. So it's just going to be 0.84. And oh, this one's a lovely one. This is like our joy moment. We're like so happy to get this one. We're like, yay, don't have to do long division. This is so great. And that is number 6. And I'm super thrilled about this one. It's 85 over 99. And as you guys know, whenever you have something over 99, it's going to be repeating repeating decimal, I should say. And it just means it's going to repeat in the hundredths place. So when you're doing this one, it means that it's going to be in the hundredths place. That's where the repeating element is. The numerator becomes the repeating element. So this is going to be 85, and it's going to repeat in the hundredths place, right? So we can see that the 99 is basically 100 minus 1, right? So this is the hundredths place, and it's going to repeat. And remember, 999, 999, these are all repeating decimals. So that's going to be 0.85 with the 85 repeating. And that's going to be your answer. And then the last one here is 111 over 250. And this is a lovely terminating decimal. I know that because you can multiply 250 times 4 to get 1,000. So it's going to be over 1,000, which means it's a terminating decimal. So this is another lovely, easy one. So you've got 111 over 250. You're going to multiply top and bottom by 4. And when you do that, you're going to get 444 all over 1,000, which means it's going to be 444 thousandths, or it's going to be 444 ending in the thousands place. So that's not repeating, it's a terminating decimal, and it's going to be 0.444, and that's how you do it. So yay, math.